Hello everyone. Today's video is going to be talking about molecular compounds, which is our last final set of rules when it comes to naming compounds. The nice thing is that the rules for these compounds are the easiest by far. The only downside to them being so easy is that oftentimes my students will then use these rules for every single type of compound, and they're really only reserved for what we're going to identify here in a bit as a molecular compound. So, simply put, a molecular compound compared to the ionic compounds that we talked about in our first set of videos is one that includes only nonmetals. Okay, so we're going to have to differentiate what makes these compounds different from others. And if we take a quick scan at the periodic table, we have to recall that the nonmetals are just these in the top right corner, right? And we also have to remember that hydrogen, which is over here in group 1, even though it's on the metallic side of the periodic table, it's a gas, which means that it doesn't really behave as a metallic element. Now, it will chemically react like a group 1 element, but we classify it as a nonmetal. Okay? So, as we're going through this process and we're trying to name some of these compounds, we've got two different categories, ionic and molecular. And we now have to be able to identify an ionic compound, one that contains metals, from a molecular compound, one that contains only nonmetals. Okay, so you notice that off to the right, we've got these metric prefixes, which have certain numbers associated with the words. So we do need to commit a little bit of these to memory. But the nice thing is that most of them do make sense to the number that they're associated with. So like 1 is mono, 3 is tri, so a tricycle has 3 wheels. Hexagon has 6 sides. The one that really sometimes will throw my students off is 2, just because you get used to like a bicycle has 2 wheels, but for molecular chemistry, we use the prefix di for 2. And then hepta, a lot of times will throw my students off. If you're in French, sometimes my students will use the prefix septa, which I think is close to the French word for 7, but we do use H, hepta, to indicate the number 7. Right? So the rules here look a little bit more complex than what we're used to. Before it was just write the first element and then the second element and put IDE at the end. But the main difference here is that we're going to first disregard the charges at the top of the group. And we're going to see that play out with the first example. And then the rest of these rules basically say whatever number you have after that element in the compound, that's the prefix that you're going to use to indicate how many are in that formula. Okay? The only major rule here that I want to point out is number 3, and that's the prefix that corresponds with the number of atoms on the first element if the number is greater than 1. And we're going to see that play out as we go through these examples. Okay, so if we start with SO2, we've got 1 sulfur, 2 oxygens. Again, if we just do a quick scan of the periodic table, both of these elements are located here in group 6, which means that both sulfur and oxygen, when they're in an ionic compound, have a -2 charge. Well, we're not going to get 2 negative ions to exchange electrons and add up their charges to equal 0. So there's a different method to their bonding for this particular compound. And so we're going to get into that in a later video. But first, when we get ready to name this particular formula, we're going to start off pretty simple. Okay, standard rules still apply. We're going to write the full name for the first element in our formula. Okay, and then now, because this is a molecular compound containing both non-metal sulfur and non-metal oxygen, we're going to use that 2 as a part of the name, and we're going to say the prefix for 2 is di. The root of that second element is ox, and then we still want to end all of our names with IDE to indicate some finality. So sulfur dioxide. Okay. The reason that we didn't put that prefix for one, mono, in front of here is that it's really kind of redundant and clunky to start a name with the prefix mono if there's only going to be one, so the name itself is indicating that one sulfur atom. And the example that I use that really kind of sends this home is this formula, which we should all be pretty much familiar with. The stuff we exhale, plants breathe it. It's a greenhouse gas. It's been in the news a lot lately. We don't call that monocarbon dioxide. Okay, so just saying the name carbon is enough to indicate that first element is by itself. And again, we call that carbon dioxide. Right? So that's really the only time for a molecular compound that we don't use one of these prefixes. If the first element is by itself, just write the name for that element. Everywhere else in these next three examples, we're going to see we use all of these prefixes. Okay? So if we move down on our list to the next example, we've got Cl2O8. So we're going to use that subscript 2 to start the name with di. We write the full name for that first element, so dichlorine, and then that subscript 8 means we're going to use the prefix oct, the root of the element ox, and then ending it with IDE. So we would call that molecular compound dichlorine octoxide. Again, the reason we use the prefixes here is that these formulas are not arranged and bonded based on the way that their charges will cancel out or their electrons are being exchanged. So there's really a multitude of different arrangements that chlorine and oxygen and sulfur and oxygen can behave with. So the prefixes here are giving us a clue as to how many elements are actually involved in this particular formula. Okay? So like I've done before, it's good practice. Pause your video, try and come up with the names for these next two examples, and then resume the video to see if you got them correctly. All right, so N2O is a little bit of a curveball here. We've got two nitrogens. So just like we had with dichlorine octoxide, we're going to start with dinitrogen. Nitrogen, here we go. But we've only got one oxygen. So this is the only time that we're going to use that prefix mono is when the second element is by itself. So we're actually going to say mono, and we're not going to double up the O, although if you do that on your quiz or your test, I'm not going to, take any points off for that. But we would say monoxide. A lot of times when you get to these nonmetals that start with a vowel, you cut the ending vowel off of the prefix. So if you said monooxide, again, same idea, not a big deal, but the actual full name for this is dinitrogen monoxide. And then for our last example, again, we've got the first element by itself. So just writing the name sulfur is enough to tell us that there's one sulfur atom in that compound. And then we've got 6 fluorines, so we use the prefix hexa, and then the root fluor ending with IDE, so sulfur hexafluoride. Okay. So pretty straightforward in terms of application. Whatever that number is now going to show up in some way, shape, or form in the name for that particular compound. The only, again, difficulty is that now whenever students see an example of an ionic compound, they immediately want to throw those prefixes on there, and we can only use it for compounds containing only nonmetals. And I'll give you an example here when we get to the end. Okay? Even easier is forming the compound from the name. All we have to do is really identify where those prefixes are. So we know we've got nitrogen, we know we've got fluorine, so we're going to write the symbol for nitrogen, we're going to write the symbol for fluorine. We don't have any prefix in front of nitrogen, so there's just one nitrogen atom. We see that prefix tri, so this is NF3. Simple. Okay. Over here we've got disulfur dichloride, 2 di, so that means that they're both going to have a subscript to 2, so we would say S2Cl2. And so for molecular compounds, we actually don't simplify this. We don't have to have them in the lowest whole number ratio. This particular molecular formula, requires 2 sulfurs and 2 chlorines to complete their bonding pattern. Okay. Dinitrogen tetroxide, again, di being the prefix for 2, so we're going to say N2, and then O tetra is 4, so N2O4. And oxygen dibromide would be 1 oxygen and 2 bromines. Okay. Now, if I were to give you the formula CaCl2, we'd first identify the fact that this is not a molecular compound. This is actually an ionic compound. So we can't use the prefix di to indicate 2 chlorines. This ionic compound is still formed from a +2 and 2 -1 ions. So this is still just going to be named calcium chloride because those two elements always behave with those two particular charges, right? Over here, we've got nitrogen, which is a -3, and oxygen, which is a -2. So there's again a different method to the way that this particular compound is going to be bonding together to complete their subshell. So we don't have to look at their charges, and we would use those prefixes to help us navigate what's the specific subscripts to that formula. Okay, so again, we don't need to worry about getting the charges if we can identify that it is in fact a molecular compound, which again, just to recap, the molecular compound is only nonmetal elements. So every example on this page contained nonmetals like sulfur, carbon, nitrogen, and oxygen.